Hey guys, this lesson's going to be over 6-2, Properties of Parallelograms. Last week we talked about properties, well not properties, but we talked about polygons in general, and we learned about finding the sum of the interior angles, finding one interior angle, and then also finding the sum of the exterior angles and then one exterior angle. Just to review, when you're trying to find the sum of all of the interior angles, you multiply n minus 2 times 180, and n is the number of sides. So for example, if it was a pentagon, there were 5 sides, so you would do 5 minus 2, which would be 3, times 180, and then that would give you the sum of all of the interior angles. To find one interior angle, you do that, but then you divide it by the number of sides. To find the sum of the exterior angles, that is always going to be 360. There's no equation for that, it's just set 360. And then when you want to find one exterior angle, you take 360 and you divide it by the number of sides. So what we're going to do today is kind of dig a little bit deeper and go a little bit into more specifics. You've heard of a parallelogram before. You know that it's a quadrilateral where the opposite sides are parallel to each other. We're going to learn the properties of a parallelogram. There's specific things about them that you need to make sure you know. In class, we'll make a foldable that you will be able to keep for your notes, and it'll help you kind of keep it organized and understand things a little bit better. So up here on the top left, it says parallelograms and their parts. A parallelogram is just a quadrilateral, like I said earlier, that both opposite sides are parallel to each other. You can abbreviate parallelogram just by drawing a little miniature parallelogram. You don't have to write out the whole word. It's okay that you use that symbol, and I will allow you to do that in class. Just some vocabulary. Opposite sides are sides that do not share a vertex. And then opposite angles are angles that do not share a side. So in the picture to the right, right there, BC is opposite AD, BA is opposite CD, and then angle B is opposite angle D, angle A is opposite angle C. Now, you also have what's called consecutive angles, and consecutive usually means next to or like in order, or like 1 and 2 are consecutive because they go one after the other. In a parallelogram, or any polygon actually, consecutive angles are the ones that share a side. And what's actually going to happen, and we'll talk about this in just a little bit on Theorem 6-4, but consecutive angles are going to be supplementary. So if you look down we'll just go ahead and go 6-4 right here. It says if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So that means that if we add angle A and angle B together, they're going to be 180. And I'm going to do an example where you get to practice that in just a little bit. Looking at 6-3, this one says that if a quadrilateral is a parallelogram, then the opposite sides are going to be congruent. So if you know what if you know what the length of BC is, then you know what the length of AD is, because they're the exact same. So there's two properties that you need to know. Consecutive angles are supplementary and opposite sides are congruent. The next theorem that you need to make sure you know is Theorem 6-5, which says that if it's a parallelogram, then the opposite angles are congruent. So opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary. Theorem 6-6 says if a quadrilateral is a parallelogram, then its diagonals bisect each other. Now remember, the word bisect means we split it in half. So basically, when you draw your parallelogram, and you'll see right here, when you draw your parallelogram and you draw the two diagonals, a diagonal is a line that goes from one vertex to the opposite. So BD is a diagonal. AC is another diagonal. Now, the point E right here that you see pointing up there, that's going to be the midpoint of AC and the midpoint of BD. So AE is congruent to EC and BE is congruent to ED. And that's going to actually come to be very handy in a little bit. And then the last theorem that you need to know for this section says that if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So if AB is parallel to CD and TEF, and AC is congruent to CE. That's important. If those are congruent, then we know that these are congruent as well. So these are things that you need to make sure you're familiar with. Eventually, at some point in time, you're going to want to have them memorized. So the more you practice, the quicker it'll become stuck in your mind or in your memory. I'm going to do a couple examples of this so you can see how this can be in action. Our first example is one where we're using kind of like a real life question here in a sense. The question says, what is the measure of angle P in parallelogram? Remember, this is the symbol for parallelogram. What is the measure of angle P in parallelogram PQRS? So if you look up here on the picture, the parallelogram is created in the lamp, and PQRS is a parallelogram. And they're giving us angle S, and they want to know what angle P is. Well, we know that angle P and angle S are consecutive angles, and according to the theorem on the previous slide, it said that consecutive angles are supplementary. So in order to figure out what this is, we know that we need to subtract 64 from 180. And when we do that, we end up getting 116, and so the answer would be C. If we were trying to find angle R, we know that angle R and angle S are also supplementary, so we would know that angle R was also 116. If we were trying to find angle Q is an opposite angle from angle angle S, so angle Q would be 64 degrees. Okay, this example says to solve a system of linear equations to find the values of x and y in parallelogram KLMN. What are Km and Ln? So one of the theorems that we talked about a little while ago said that the diagonals bisected each other. So what that tells us is that LP is equal to PN and KP is equal to PM. Now a system of linear equations, I'll just circle that, is basically it's two equations that have two different variables in them. But what happens is your variables are mixed up and you have two variables in one equation. And so by creating two equations, you can either use substitution, elimination, or graphing to figure out the values of x and y that make both of them work or make both of them true. My favorite is elimination, but not all the time is it set up for that. Substitution, usually it's going to end up being what you're going to have to use. If you see in here, we have just a single x, so substitution's probably going to be what happens. Now, when you set this up, we know that LP is equal to PN, and we know that LP is x, and that is equal to PN, which is y plus 2. In this situation, we can't solve for either variable and find its actual value because there's two different variables in that equation. So instead, we want to set up a second equation below that, and that would be a system of linear equations. Kp is y plus 10, and Pm is 2x minus 8. Now, here we have a system of linear equations, two equations with two unknowns. What we can do in this case is take this equation, x equals y plus 2, and substitute y plus 2 in the x of the other equation, or all of the x's of the other equation. So we're going to rewrite this equation, y plus 10 is equal to 2 times, but instead of putting x, we're going to put y plus 2, and then minus 8. Now what happens here, what you can see is that you end up having only y's in this equation. And that's the ideal situation that you want to be in. You want just one single variable so you can solve for it. So I'm going to go ahead and do the algebra here. Y plus 10 is equal to, distribute that guy, so 2y plus 4 minus 8. Y plus 10 is equal to 2y minus 4. Subtract the y from both sides. 10 is equal to y minus 4. Add the 4 to this side, so 14 is equal to y. So we end up getting that y is 14. And then we got to figure out what x is, but we already know what y is, so we can just plug it in, and I would suggest plugging it into this equation. X is equal to y plus 2, y was 14, so x is equal to 14 plus 2, which means that x is equal to 16. So it said define x and y, so there's x and y, but it also said define km and ln. Well, km is the entire diagonal going from left to right, increasing, and so we can plug in 14 here. So 14 plus 10, this is 24, and then that makes this one 24 also. So km is 48. And then we plug in our x value, 16, so this is 16, which also makes this 16, and 16 and 16 would make 32. So ln would be 32. Again, systems of linear equations, this is something that you did in Algebra 1. If you want to do a little bit of research on that, you can just type in Google systems of linear equations, and you can find many videos, many websites that have the different ways to solve them. So if you're interested in doing some kind of research and understanding how to solve linear equations a little bit more than what I showed you here, go ahead and check those out. Now, this problem I'm not going to do. I want you to try it. I want you to solve it the way we just did the last problem. Use elimination if you want to. You can do substitution like I did. But I want you to solve this problem, and I want you to bring it to class on the day that we cover 6-2. So that way I can check it, and you can come and ask me questions if you need. But I'm going to check that for a grade. So make sure you have that ready to go when you get to class. Have a great evening, and I will see you guys soon.